would we not recommend for the enuresis? Is it the enuresis alarm? Is it the oxybutynin? Is it tolterodine? Or is it the desmopressin? So if we want to look at our answers here, the one that is most correct is the answer D, which is the desmopressin. This one we will not recommend for the enuresis. Why? Because if we go to our reference, which is the CTC, in the enuresis chapter, they will say about the desmopressin the following: that it should not be used in children with kidney disease, heart failure, diabetes, mellitus, or cystic fibrosis. So this is why from all our answer for this kid who was type 1 diabetic and who has a diagnosis of nocturnal enuresis, the least favorable answer will be our desmopressin. Enuresis alarm, oxybutynin, and tolterodine would be actually 3 other options for this patient. Another question related to our previous case: what are the risk factors for enuresis? We have diarrhea, hyperactivity, constipation, or male gender. And the right answer is constipation. Again, our reference is CTC in Table 3 for possible interpretation of enuresis. We can find, between other things, constipation. So other factors would be like family problems, daytime frequency, or urgency. So the most appropriate risk factor is constipation. Now, the doctor decides to start OW on oxybutynin immediate release 5 milligrams BID. What cascade of medication is most likely to be seen taken by this patient? So what we mean in this answer is that, let's say this patient was started on a certain medication. What other medications are we most probably gonna see? Is it loperamide and saliva substitutes? Is it polyethylene glycol powder and saliva substitutes? Is it both of the above options, or is it none of the above options? It's actually answer B. It's the polyethylene glycol powder and the saliva substitutes. And why is that? Because as we know, oxybutynin could lead to constipation and dry mouth, which are manifested by the anticholinergic side effect of the medication. So the patient might be using those 2 medications afterwards. Now we move on to a calculation question. So you are the pharmacist on the team on the ward, and a female patient who weighs 75 kilograms is prescribed digoxin, and the team asks you to calculate the loading dose and the maintenance dose to achieve a steady state concentration of 11 milligram per liter. And we're going to assume that we have a volume of distribution of 25 liters and the T-half of the medication of 7 hours. So what would be our calculations for the loading dose and the maintenance dose? So, as we saw in our course, that we have 2 formulas for loading dose and for maintenance dose. The loading dose is the steady state concentration times the volume of distribution, which is 11 milligrams per liter times 25 liters, since we have them in our given. And be careful that here we have the same units, so we have liters, which will cross out the liter, and we have the milligrams, and that's why our answer was in milligrams. So our loading dose will be 275 milligrams. Now we come to our maintenance dose, which is steady state concentration times the clearance. So in this formula, the steady state concentration is known, but the unknown is the clearance. But there is a way to get this clearance, and it is the following. The clearance, we know that it is equal to Ke times V. And Ke, we know that it is 0.693 over the T-half. T-half, we have it in our question as a given. So we can calculate the Ke easily, which will be 0.099 hour minus 1. We go back to calculate our clearance since now we have V as a known and Ke as a known, which will be 0.099 times 25, which will give us 2.5 liters per hour. Again, be careful for the units. So we know that our V is in liters. We know that our Ke is in hour minus 1. That's why when we multiply them together, we're going to get the unit as liter per hour. We go to our maintenance dose formula, which we had here, but we had to figure out some of the unknowns, and now we have them all. So the steady state concentration times the clearance is going to give us 27.5 milligrams per hour.